Good morning, ladies and gentlemen. We're going to do 8.6b, solving rational inequalities. So we're going to use a combination of math and graphing. And it's kind of an interesting way to think about solving an equation when we get to the graphing portion. But let's talk about steps to solve first. First thing you're going to do is move all numbers to, bad grammar, all numbers and variables to the left-hand side of the inequality. So you want it to look like you're setting an equation equal to 0. So like if I had x squared minus 2x plus 1 is greater than x, if I wanted to solve that inequality, I would move the x to the other side. So we'd have x squared minus 2x minus x plus 1 is greater than 0, and then I would continue to simplify. So when we start solving our rational inequalities, we want everything on the left-hand side. All right, the second step is that we're going to manage the left-hand side. So that might mean putting our rational expressions together, finding the lowest common denominator. All of those things would be steps that you would potentially need to take. Number 3, we're going to find the critical values. Somebody loves me. That's nice. Woohoo! We're going to find our critical values, and I'll talk about what those are soon. And then we're going to graph them. Okay? And graphing is going to be different and unique. So if I have something that says greater than or equal to 0, okay, it means I'm looking for portions of the graph that are above the x-axis. Okay? And actually, if it's greater than or equal to, it would include the x-axis and then go up above. Okay? If I have less than or equal to 0, I want all portions of the graph that are below the x-axis. Okay? So it's going to be kind of cool. And then because I'm looking for intervals of information, I'm going to report my answers, and I'll put solutions in interval notation. All right, so now let me do an example because I think it will make it better. Sorry. All right, so we're going to solve. So our inequality is going to be x squared minus 2x plus 1 over x minus 2 is greater than x. So the first step said move everything to the left. So if I do that, I'm going to get x squared minus 2x plus 1 over x minus 2 minus x, and then is greater than 0. And I left a little bit of space because I'm going to have some math to do. I need to put these two expressions together. My lowest common denominator is x minus 2, so I'm going to multiply this fraction by x minus 2 over x minus 2. Okay? And I'm going to go sideways because I'm kind of at the bottom of my paper. So if I do that, then here's the first fraction, minus 2x plus 1 over x minus 2, and I'm going to subtract x squared plus 2x I distributed over x minus 2, and then there's my greater than 0. So now I need to combine like terms. Okay? All right, so if you'll notice, the x squareds go away, my 2x's go away, and I'm left with 1 over x minus 2 is greater than 0. So now I need to look for a critical value. Okay? And another name for my critical value is I'm looking for my vertical asymptotes. Oops, spelled it wrong. Vertical asymptotes. And I'll show you why. So I guess I am going to have to go to another sheet of paper. Bummer. All right, so let me rewrite the equation. I have 1 over x minus 2 is greater than 0. So my critical value, or my vertical asymptote, okay, is going to be x minus 2 equals 0, so I'm going to get x is equal to 2. All right, so I'm going to go ahead and graph this portion. So I have a vertical asymptote at 2, okay? I have a 1 in the top, so my graph, I'm going to have a horizontal asymptote at y is equal to 0. It's going to look something like that. All right, so now let's talk about our inequality. So I'm trying to find when the values are greater than, highlight that so we can see it, 0. So if I look at my graph, this portion of the graph is less than 0. This portion of the graph is greater than 0. So my solution to this, I'm going to write solution, and I'm going to write f of x, because that was our function, is greater than 0 from not included 2 to positive infinity. So it's almost like the domain, but not quite. All right? Okay. So again, I'm looking at my graph, and my graph is above the x-axis from 2 to positive infinity. Alrighty, so now let's do another example, okay? So I'm going to again say solve, and this one's going to be 6 over x minus 2 is greater than or equal to a negative 4. So remember, the first step is to move everything to the left-hand side, okay? So I'm going to have 6 over x minus 2 plus 4 is greater than or equal to 0. My lowest common denominator is x minus 2 again. I'm going to squeeze that in right there, so I'm going to multiply by x minus 2 over x minus 2. So then it becomes 6 over x minus 2, and then I'm going to have plus 4x minus 8 over x minus 2 greater than or equal to 0. I'm going to combine like terms, so 6 minus 8 is a negative 2 plus 4x over x minus 2, okay? All right, and I'm going to rearrange this a little bit because it'll look better. So I'm going to write 4x minus 2 over x minus 2 greater than or equal to 0, okay? All right, I'm not going to factor the top because it's not going to reduce my fraction any at all. My critical value then is going to be x minus 2 equals 0, x is equal to 2. So remember again that this is my vertical asymptote. I do have, I'm going to write vertical asymptote beside it, a horizontal asymptote at, remember these have the same degree, so my horizontal asymptote is going to be y is equal to 4 divided by 1, which is 4. So now I'm going to sketch my graph. You always need to see a picture of your graph. And I'm going to put my asymptotes on my graph. So I had a vertical at x is equal to 2. So I'm going to put that on there. And then I have a horizontal at y is equal to 4. And then my graph looks kind of like this. And you can get this information. You can use your grapher to help you. All right, so now let's look at, and I'm going to box this so we see it in all of our work. We want to know when is the function above or equal to the x-axis, okay? So it's above or equal to the x-axis to there, and then it's above the x-axis there. So if I report my answer, in interval notation, I'm going to say that f of x is greater than or equal to 0. Now before I finish, I need to find this point right here. And remember to find the X intercept. It comes from the numerator. So if I have 4x minus 2 equals 0, then I get 4x is equal to 2. X is 2 over 4. So that's going to be a half. So I know that this point of intersection, I'll write it over here because I can't squeeze it in, is a half. So that means for my function, it's going to be greater than or equal to 0 from a negative infinity to 1/2. The 1/2 is included, okay? And then it's going to be unioned with not included 2 to positive infinity. The reason the 1/2 is included is because that's where the graph is equal to 0, so that value is included. And then I start on the other side of my vertical asymptote, not included because the values will never get there, to positive infinity. And so this would be my solution to that particular problem. All right, let's do yet another example, because some of these problems are just easier once you see lots of examples. Okay, so I'm going to have x minus 5 over x plus 3 is greater than 1. First step is to move everything to the left-hand side. So I'm going to have x minus 5 over x plus 3 minus 1 is greater than 0. And I left myself some space. My lowest common denominator is x plus 3. So I'm going to multiply this by x plus 3 over x plus 3. Simplify the left, and I'm going to have x minus 5 minus x minus 3 over my x plus 3, and that's going to be greater than 0. So if I simplify, my x's cancel, and I'm going to get a negative 8 over x plus 3. Okay? Did I do my math right? Negative, negative. I think I did. Is that true? I think so. Okay? And I know that that's going to be greater than 0. So I have a vertical asymptote at x is equal to a negative 3, and remember this is called a critical value. The degree in the bottom is higher than the degree in the top, so I have a horizontal asymptote at y is equal to 0. So now I'm going to sketch my graph. Okay? Alrighty. The negative is going to flip my branches, so I'm going to put my asymptote in here. Alrighty. I'm going to put, sorry, my brain and my mouth aren't working at the same speed. There's my negative 3. Here's my vertical asymptote. I have a horizontal at y is equal to 0, so my graph is going to do something like this and this. Okay? All right. So my inequality said, when is the function greater than 0? Well, if I look at my graph, it's greater than 0 up there. So my solution would be from a negative infinity to a negative 3, not included. And that is my solution. Okay? Alrighty, let's do one more problem, and that's a little bit more entertaining. Okay, so our last example. Alright, so again it's going to say solve, and I'm going to have 2 over x plus 6 is greater than a negative 3 over x minus 3. Alright, first step is to move everything to the left. So I'm going to have 2 over x plus 6 plus 3 over x minus 3 is greater than 0. So this time my LCD is going to be x plus 6 and x minus 3. Okay? So my first fraction has the x plus 6, so I multiply by the x minus 3. So I'm going to have 2 over x plus 6 multiplied by x minus 3 over x minus 3. The second fraction has the x minus 3, so I'm going to multiply by x plus 6 over x plus 6, and that's going to be greater than 0. So now I need to distribute across the top, so I'm going to get 2x minus 6 plus 3x plus 18 over x plus 6 and x minus 3, and that's going to be greater than 0. If I simplify on the top, I'm going to get 3x plus 2x is 5x, and 18 minus 6 is 12 over x plus 6 and x minus 3, and I want it to be greater than 0. Okay? So let me write down my critical points. My vertical asymptotes, x is going to equal 3 and a negative 6. The degree in the bottom, x squared, is higher than the degree in the top, so I'm going to have a horizontal asymptote at y is equal to 0. Okay? Now I'm going to sketch my graph. All right? So I have 2 asymptotes this time, one at a negative 6, one at 3. Okay, so those are my verticals. My horizontal is here at y is equal to 0. And then I would use my grapher to help me find where all of my branches go. Okay, and so this is going to cross, and then I'm going to have this one. Okay, so because this is crossing, I want to find that value. So if I let x equal 0, okay, I'm going to end up with, I'm going to write my X intercept. Okay, and I'm going to let x equals 0, so I'm going to solve. So I get 12 over 6 times a negative 3, which is 12 over, I think I did bad math in my notes, 18. Both are divisible by 6, so it's going to be 2 over a negative 3. So this is going to be a negative 2/3, okay? And that's where it crosses. Alrighty? I'm just checking my work to see if I made any mistakes. I have no idea. I think I was an airhead in my notes. Okay, so now let's write our solution, and I'll kind of squeeze it in here down on the bottom. So when is my function greater than 0? I get out my handy dandy highlighter. It's greater than 0 from there to there. So remember, this time that point's not included because it says greater than. It doesn't say greater than or equal to, and then this piece is included. All right? So if I write that interval notation, it's going to be from a negative 6 to a negative 2/3, not included because it doesn't say equal to, it just says greater than, unioned with 3 to positive infinity. Okay? And this is going to be my solution. Okay? I'm going to write in my notes that I screwed up. Alrighty, so we will spend a couple of days on this because these are kind of fun. But let me give you your problems to start. Alrighty. All of these are going to say solve. Okay, so you do want to list your asymptotes because that's helpful when we're solving. MPT, such a weird word to spell. And then you're going to want to sketch the graph. Okay, because that's really helpful in writing the interval notation. Your first problem, you're going to have 10 over x plus 2 is greater than 0. The second problem, x squared minus 4x plus 8 over x minus 1 is less than x. And then your last problem is 3x plus 2 over x minus 1 is greater than x. All right, so remember to find all of your asymptotes. Make sure that you combine everything on the left-hand side. So find your vertical and your horizontal. Sketch the graph. You may need to find an intercept, and so I'll just write a remember note that your X intercept comes from the numerator. Okay, so comes from the numerator. Okay. And then we'll be done, and we'll go over these in class tomorrow. So good luck with these problems, and I'll see you soon.